Hello, everyone. Thank you for joining this seminar series organized by the Empathic Computing Laboratory. I'm your host, Aladdin, and our guest speaker for today is Susanne Schmidt, who is currently a postdoc researcher at the University of Hamburg in Germany. Her research interest is in multimodal human-agent interaction and has done a lot of research since 2015. That's correct. The title of the talk, How Much Realness Do Virtual Agent Need? The talk will be roughly an hour, followed by a brief question and answer session. Thank you for joining us, Susanne.
Thank you as well for the invitation. I hope you can see my presentation correctly. If you could, yeah.
Yes, we
Great.
can.
Okay, so thanks to everyone for joining us today. Yeah, we are going to discuss one of my most favorite topics, I would say, which is virtual agents, and particularly the social relationships between agents and humans. So you can already see the question we are going to talk about. And I want to explore different aspects of it, probably not all of them, as you can imagine, but at least I would like to give you an idea of the complexity of this question, but also of its relevance. And before doing so, I'd like to explore one of the concepts mentioned here a little bit more, which is the concept of realness. So what does it actually mean for virtual agents to be perceived as real? And in the past, perceived realism was very much linked to the rendering quality. And rendering quality is something where we experienced a huge leap over the last, I would say, 1.5 years. And to illustrate that, I just tried to select it for examples which were released recently. You can see them on the slide here. And I think they are not only remarkable regarding rendering quality, but they also have, each of them at least has a different aspect, which is super exciting, at least in my opinion. So on the top left, for example, you can see Rosie. Rosie is a virtual influencer. So she has her own Instagram account where she provides styling tips, life advice, stuff like that. And actually she has more than 130,000 people who are already following her, although she just started with this. So what we can observe here is that these realistically looking agents are entering our daily lives, and in a way that honestly I couldn't have thought of just a few years ago. So I think this is a really exciting development we can observe here. As a second example, on the lower right, you can see a boy band. I think they just debuted like last month, and their name is Superkind. And what is super interesting here is that a virtual agent is teamed up with other real bandmates. So you can see a fully rendered virtual agent in the center, which is surrounded by 2 of his real bandmates. And then we have the last 2 examples, which are certainly the ones I'm personally most excited about, because I think they can make a huge difference in our research. First, there's Emma on the lower left, which was developed by a company called Cyberdynamics. And they in turn were acquired by Unity in the beginning of the year. And what makes it so exciting to me is that we cannot only render such realistically looking agents, probably we could do that before, but we can actually do that within interactive game engines like Unity and Unreal. So we get the chance to actually include such agents in human agent interactions that we are developing and using in user studies, for example. Yeah, Epic pushed this even a bit further. They are not only presenting meta-humans, but they also released a character creator. And this allows indie developers, but basically everyone, to create these high quality agents for their own applications, for their own games. So what we can see on this slide is that one aspect of realness is certainly the rendering quality, but I'd like to go a little bit deeper and show you that there are other aspects as well. So if we take a look below the surface, we see that just from a technical perspective, there are a lot of different systems involved when creating believable agents. I assume that maybe some of you already know a similar scheme from a lecture by Mark. So it shows the main components between humans and agents when they're interacting. And the first component is the blue one, which is covering all input modalities between human and agent. Then the collected signals from these different channels are forwarded to what I call a core AI, which task is to calculate an appropriate reaction of the agent. And it can use different data for that. It could use cloud services, internal databases. So this is somehow represented by this arrow on the right side of the slide. And after doing this, it has to represent the reaction to the user again. And this is again a multi-sensory process. So it can render a 3D model, for example. It can synthesize speech or even do some haptic or physical simulations in general. And to get an impression on how far we have come in each of these single components, I'd like to at least briefly show some examples for each of them. And I don't want to do it on the example of these commercial systems that we just saw, because all of them have certain limitations. So for example, Emma that we just saw looks super cool, but it was a tech demo by Unity, so it's not really clear if and when we can actually use it within the engine. And on the other hand, meta-humans can be used within the engine, but currently it's prohibited to use them to, for example, test machine learning algorithms or test any new kind of technology. So therefore, everything I will show you in the next few minutes is stuff that we are actually working with in our group. And it's something that we can use in research projects to build interesting human agent and interactions. So first of all, I already mentioned it, we have to somehow record the user's actions, behavior, so the agent can react on it. This was a task which was really difficult a few years ago to do in real time. Today, there are a lot of options. If you want, for example, to have live speech recognition, you can use IBM Watson, you can use Google Speech to Text. And also we have some computer vision libraries, such as OpenCV and DLib, which allow us to detect certain facial landmarks, which can then be used for different follow-up tasks. And you can see them here on the left image, demonstrated by my colleague, Nidi. Okay, just try to move your video panel. Now I get it. So you already saw the video, I guess, on the right side. Maybe not. I will.
Not yet.
Now it's working. Okay. So what we are using it for example, is to detect some emotions of the user. We also use it to just recognize the user, to be able to create interactions which are more individualized. So this is something which is somehow exciting, that we can use these algorithms now to actually use it within interactions in real time. Then the signals that we collected, I mentioned it earlier, they can come from the camera, they can come from the microphone, and they will be sent together to our core AI. So here we currently have two options. The first one is to describe our whole interaction using a so-called dialogue tree. So this is what is illustrated here. This means that for each intent the user might have, we can create a specific node, and we have to specify how the assistant should respond if this intent is recognized. You can see a response, it's a little bit small probably on the right side. For example, for this specific node, if a user is recognized, for example, by this face capturing system, then the agent should respond with, sure, what is your name? What this also means is that we have a limited flexibility. So there is some machine learning involved. especially in a recognition of the user's intention, but the output of the agent is always fully deterministic. So this also means when the user is asking something that was not prepared by the developer in this dialogue tree, then the agent will just say something like, I didn't understand, can you rephrase it, or something like that. On the other hand, we have a second option, and I think this is a very exciting opportunity that we can now work with very complex language models like GPT-3 from OpenAI. And I will say right away that these models are not inherently better than dialogue trees, at least for our specific purpose, but I think they do provide some flexibility. And yeah, I also think they're just fun to explore. So if you haven't yet, I can recommend. It's really a nice thing to learn from and to check how it can be used in our research. In our project, we are using this OpenAI API to access GPT-3. And here you can see one of the dialogues that was just created for one of our museum applications. So you can see that the developer just has to create a prompt. This is the first line on this slide, which is describing the situation. And then GPT-3 can calculate appropriate responses by the virtual agent, and they are highlighted in green here. What is also interesting is that we can even attribute some personality traits to the agent. So for example, I just added, she's very sarcastic to the prompt, and immediately the responses of the model are changing. So for example, in the first response, it's actually not a correct answer anymore. The agent is just making fun of the user. Second one, it's still correct, but it changed a little bit how the response is phrased. So the good thing about such models is that they always answer. It doesn't matter what the user is asking. And also what we found that for factual questions like the ones about Napoleon, it often gives the correct answer. And this is because the model was, of course, trained on huge data sets, including Wikipedia articles and so on. The downside here is that we lose the control over the responses of the agent that we had earlier when we used the dialogue tree. So overall, I think it's a new option for us as well. We are actively exploring it. Currently, we are still using dialogue trees more often because of the control that we have. But the question is if we can integrate such flexible language models into the conversation, maybe in parts that are not that critical. So maybe for small talk or something like that. And after this core AI generated an appropriate response, the agent has to somehow deliver it to the user. And as mentioned earlier, this leads to a very crucial part of our whole system, which is the rendering. So here you can see the development of our own agent, Louise. Actually, it's interesting to see the agent we just had to work with 4 years ago. So it was not a long time ago. And I was very proud of it, to be honest. Now it feels quite creepy. And what is also interesting is that the latter 3 models are actually the same. So the mesh is the same, the textures are the same. It's just about rendering in Unity. So we changed the lighting, we have post-processing effects, we have new shaders, a different rendering pipeline. So this already changed a lot in the last few years when we think about rendering quality. The next component, which is often not the focus of agent development, but in my opinion, it's just as important as the rendering quality itself, and it is the behavioral simulation. So previous studies have shown that a realistic appearance is only received positively by users if the quality of the agent's animations is also matching. So we used to rely on our own animation skills earlier, or we had to use pre-existing animations, but actually since last year, there's finally an official face capturing app from Unity, which was demonstrated here by my colleague Kelly. And of course, we cannot use it in real time. It has to be prepared, but we use it for a lot of different use cases, for example, to create convincing idle animations, or just things that you wouldn't find online, like just a face when the agent is aware that you're talking, or just a face when the agent itself is reading. So there are a lot of subtle behaviors that we can animate with this face capturing. Another important channel is, of course, the speech output of the agent. And again, I have to say, I haven't been in research for 30 years, but still I have witnessed myself this transition from using real recordings of people. So I actually asked my colleagues who had a nice voice, could you please record stuff for my user study? And now the transition to these text-to-speech engines, for example, from Google or Descript. And I just wanted to show you two of them to give you an impression.
This was generated using the Google Text-to-Speech API.
And this was generated based on training recordings of my voice with a length of just 10 minutes. Okay, I hope you heard them. Actually, I don't hear them myself because of my strange setup here. So the delay worked? Yeah, thanks, Elodie. The delay for Google API is good enough that we can actually use this for our own interactions. On the other hand, the overdub example on the right was pre-generated. I have to say there is an API for overdub as well, which should work within 2 or 3 seconds, but I haven't had the chance to test it yet. I just wanted to show you that even with sparse training data, so we just had 10 minutes of recordings of my voice, we can still create quite convincing speech, which is synthesized. Of course, there are artifacts still, but I think it's still an interesting opportunity. And if we combine all of these systems, we can get, I would say, a recent result, even without the manpower and the computational power that big companies like Unity have. Here's an example of this.
Hi, Louise. Have you seen Frank today?
Yeah, I saw him in the lab around noon.
So why I showed you all of this is because I personally think we are heading towards a very interesting point in time regarding virtual agents. In the past, the maximum possible rendering quality, and thus our idea of realness that I just mentioned earlier of agents, was always dictated by the technology. And based on these developments that we just observe, I think that it's reasonable to assume that at some point all of these technical limitations will diminish in the next few years. And the question that arises from this observation or from this development is, does this really mean that we finally achieve fully realistic agents, or is there more to that? Are there maybe other aspects of humans that we have to simulate, or are there perhaps human characteristics that we don't want to simulate? Maybe we want to intentionally create this gap between humans and virtual agents, where we decide agents should remain superior or inferior or just different from humans. And this is a question I'm very much interested personally. I hope you are too, at least a little bit. I think maybe this is the reason you came here. So in the remaining time, I'd like to discuss 4 questions with you that are somehow related with this overarching question: how much realness do virtual agents need? And the first one is a very fundamental one. Probably if you're researching virtual agents, you thought about it as well, which is just, do agents need a body? And although it's very basic, I know, I'm still very interested in your opinion on that, because I think there's always a difference between what the research tells us and how people are actually using a specific technology. And to make it a little bit easier to grasp, I'd like to limit the question first to personal assistance. So the question is, could you imagine to have an embodied virtual agent participating in your daily life at home, just as a real human, as it is depicted in this first example, which is from the video game Detroit Become Human. So there the center figure is Kara, which is actually an android, and she's just part of the family in some sense. She's interacting with the child, is like a trust person for the child, for example. The alternative is depicted on the lower image from the movie Her. Here the virtual agent is represented by just a voice that the guy in this image can hear via his earphones. And nevertheless, in this movie, the character is able to create a social relationship to the virtual agent, which is Samantha, I think, in this case. So before talking a little bit about empirical research and what it tells us about embodiment of agents, I'd like to forward this question to you. So what do you think, just from your first intuition, what would you prefer for the future when you imagine that we do not have any technical limitation? So assume that it's not necessary to wear cumbersome headsets, and the virtual agent could just be embedded into your environment, in your work environment or living environment. And I created a survey on that. I think Aladdin can share it, if you don't mind. Thanks.
Yeah, it should be now.
So it would be great if you could just intuitively try to answer this question. And yeah, actually, I will collect the responses as well, because I'm also interested how this develops over time, because I think we will see a shift in the next few years. So yeah, I not only included this because every website says in engaging Zoom talks include surveys, but because I'm actually interested.
It's really good. So you have 11 answers.
Perfect. So actually, I cannot. I think you can share the results, right?
Yeah. Let's see. Okay. How about now? Do you see the results?
Yeah. Great. Okay, so 2/3 said no, it shouldn't have a body. 1/3 said it should have a body. That's actually interesting because it also reflects the research that a colleague, I think Lucy, she's still here, of mine has just done recently. So we see that a lot of people are still tending towards the voice-only agents. And I think one reason for that is that we are very much used to such agents through our current technologies. So here you can see 3 examples, which I think quite common. So first we have, of course, our personal home assistants that are still used for mostly primitive tasks. So here I could say maybe embodiment isn't even that important, to just provide a time or to manage my shopping list. But this is something people are very much used to. And then the other 2 examples are disembodied agents integrated in fitness trackers, but also from our own project, which is about museums. They are also integrated into audio guides. And if we return to our very first question, we find that such voice-only agents do not really simulate humans well. So of course we can make phone calls to real humans as well, but the particular tasks that you can see on this slide are not really reflecting situations where you would usually call another person. So referring to our initial question, a more realistic implementation of the depicted agents would add a virtual body to the voice. And one positive aspect or one opportunity that arises from this is that we could actually use a contextual visual representation. Of course, this is also possible with voice, but it's much more difficult. For example, for Napoleon, the question is, how is he even speaking? So we probably would add some stereotypes to make clear that it's Napoleon, but with a body representation, this would be possible. And based on these considerations, we phrased our own research questions, focusing on one of these mentioned settings, which is the 3rd one, the museums and virtual guides that are guiding people through a museum. So our research question was, are embodied virtual guides performing better than voice-only guides in terms of various measures like co-presence, social presence, credibility, and also their ability to impart knowledge? You can see that we had a second research question as well, but because of the overall topic of this talk, I will focus on the first one. So we invited 24 participants to the study. All of them were experiencing 4 episodes of the Apollo 11 mission, each of which with a different guide. And 2 of the guides were disembodied, 2 were embodied, and also 2 of the guides represented a very generic guide, which could be just a normal person working in a museum. 2 of them were depicted as Neil Armstrong to have a more thematically close character. You can see the 4 episodes with an example mapping of virtual guides to each of the episodes. And the setup we used was a cave with projections on 3 walls and also the floor. Maybe you can see it, I think, in the last image. You can see the seams a little bit. And we included different aspects of natural behavior. Some of them I just showed you earlier. And we also tried to generate the 3D models of the faces from pictures of Neil Armstrong to make it more convincing to our study participants. As I already showed in our research question, we were interested in multiple dependent variables. I won't explain every detail, but at least I'd like to summarize the main message of each measure. So all of the following diagrams will show 4 bars, 1 for each agent that was tested. And in the context of embodiment, we are particularly interested in the comparison between the first 2 bars, which represent embodied guides, so the gray and the green one, and the last 2 bars in blue and purple, which represent the disembodied guides. So our comparisons are always the left 2 versus the right 2. The y-axis in this case is the credibility, which was measured with a questionnaire. And you can see that there is a significant difference between embodied and disembodied guides, with embodied guides reaching a higher mean score in credibility. And the same was found for different measured aspects of presence. So for spatial presence, social presence, presence as engagement. So again, embodiment performed better than disembodiment. For learning, we also found a significant difference, but this time disembodied agents achieved a higher mean score than embodied agent. This is, however, just true if you consider visual facts, which is shown on the x-axis here. So in our study, participants performed an oral exam in the end of each condition, and we covered numerical questions, social questions, spatial, and also these visual questions. And this was the only dimension where we found a significant difference. So this is most likely because the embodied guides somehow distracted study participants from the exhibits and from visual details of the exhibits, which of course is important to be aware of and to think about if you are creating hybrid museums or completely virtual museum experiences, that guides may also have some negative effects on the learning outcome, not only positive effects. And then the final measure, which is probably most important regarding our initial question, because this could be actually the factor that decides whether a user would actually integrate a virtual agent with a body in his daily life. And the diagram shows that embodied agents were perceived as more attractive, more perspicuous, stimulating, and also more novel. And similar positive effects were also shown in other settings, not only the museum setting, in other previous studies. So we see that embodiment from the research perspectives has a lot of these advantages, but we also saw in our survey before that still the majority of you, and I think this is quite representative, the sample, would still favor disembodied agents in their personal environment. And my colleagues, Lucy, who is here, and also Fariba Mostajaran, conducted a study which actually reflected this behavior that we just saw. So in the preliminary setup, Fariba considered different agent representations for a typical personal assistant like Amazon Echo. You can see the different states on the upper image. And then Lucy extended the setup to perform a full study that investigates cognitive physical performance of users. And what is interesting here is that the agents observe the participants during the task without interfering. So just the mere presence of an agent could actually influence the outcome of a user. And this is actually a scenario which is kind of similar to how it would be if we would integrate embodied agents in our daily life, because they're also permanently present. Maybe they are not interacting with us all the time, but still their presence may have an influence. And actually in her study, Lucy could show that, first of all, the social presence is increasing along the spectrum from voice only to full body agents. And she could actually confirm what we just saw in our survey earlier, that the user preferences are kind of different. So for the two conditions, mouth and head only, we have only 3 participants in total who preferred this. But for the other more extreme conditions, we actually have a similar count of participants who chose each of the conditions. So we see that even our empirical research, this opinion or the diverging opinions are somehow reflected. And this is something we have to have in mind when we create agents, that on the one hand, our research suggests there are a lot of positive aspects of embodiment, but on the other hand, maybe users are still not ready to use them in their life. So what did we learn just from these examples? So we saw embodied guides have positive effects on presence, on credibility, on user experience. So we just saw it for this specific museum setup, but I think some of the measures are also very important for other scenarios. Others, for example, credibility or learning, are maybe more interesting for this specific scenario. But still we can learn from that. So for example, if we need a very credible agent, for example, in a therapy context, or as in a teacher context where we assume that the agents should be knowledgeable, should be credible, then maybe an embodied guide could be the better choice. And as I mentioned multiple times, we have also very diverging user preferences here. So I think the suggestion for now would be to go with an embodied agent if the measures that I mentioned are really of major importance. But maybe if users have to work with an agent repeatedly, then the disembodied agent might still be the better choice. And in my PhD thesis, I actually introduced a concept. It was called blended spaces. And the idea here was that we seamlessly transition between different states along the virtuality-reality continuum. And this could also be an approach here, that we say, for some scenarios, we can just blend in the agent's body. For others, maybe it would be better to just be in the completely real environment, because without any distracting factors. Okay, our next question concerns one specific modality of agents. It's, do agents need to be physical? And if we think back to our scheme of human-agent interaction and the example implementations that I just showed you earlier, we realize that there is a certain asymmetry between users and agents. So taking this example of a golf game here, I think what is very natural is that the user could, of course, interact with a physical golf ball. What is more remarkable is that the agent could, the user could also be tracked, and by simulating physics, the user could also interact with a virtual golf ball. If we consider the other side, the virtual agent would be able to interact with a virtual ball as well, but it's much harder to implement virtual physical interaction, which is the virtual agent influencing the state of a physical ball. And again, we have a survey. The question to you is, just from your intuition, do you want agents to be able to manipulate properties of such real-world objects? I know probably there is no universal answer, but just first intuition. And Aladdin, if you could share survey number 2, please. Thanks. And in a second, again, we will see what the research tells us and try to come back to our initial question, how much realness do agents need actually? So we have 10
responses.
Perfect. Okay, interesting. So again, majority says no physical interactions. That's a little bit bad of the research for the research project that I will just show you. I hope it can convince you a little bit that it's not completely useless to have such interactions. But I understand completely that this is the current sentiment here. And this is interesting again, because it would mean that actually the agent wouldn't simulate humans perfectly, because humans, of course, can interact with our physical environment as well. Okay, so here you see 2 examples of related projects. Actually, I saw that King Zhu was having a talk here a while ago as well. So maybe some of the examples you already know, because the group around Greg Welch at University of Central Florida did a lot of research regarding this virtual physical interactions. And in these 2 examples, you can see how a virtual agent is able to change the pose of a real physical object. In the wobbly table, this object is the table itself. And for the physical virtual table, it was a small physical token, which was used in the context of a tabletop game. And there are other projects by this group as well, for example, exploring how simulated footsteps of an agent could influence the user. And these footsteps are simulated by vibrotactile feedback in the floor, for example. So overall, these interactions from Greg's group were focusing on the moment of an agent interacting with a user. And we wanted to introduce a different form of virtual physical interactions that create something which actually persists when the virtual experience is over. So if you think about it, since the feedback of agents is usually completely virtual, it also disappears as soon as the user, for example, is removing the headset, is leaving the cave. And therefore, all proof of existence of the virtual agent is disappearing as well in this moment of finishing the virtual experience. And we wanted to address this by not only testing a virtual physical interaction that involves the manipulation of a pose of a physical object, which we did using a robotic golf ball, but we also wanted to let the virtual agent manipulate the surface material of an object. And by this means, the agent could write on a real piece of paper, and the user could take this piece of paper out of the virtual experience, which we hoped at least could add a new quality to virtual agents. And you can see that we implemented this by using a terminal table. So here are the 2 prototypes that we built. The first one that we utilized for manipulating a physical object was a robotic ball, and we used Sphero Mini here, which has the size of a golf ball. It included a motorized counterweight at the bottom, and this can move within an outer shell, and by this movement it creates a weight shift, and in turn the whole ball is moving along the x-axis and z-axis. It means it can move around the ground plane. And our contribution here was that we implemented a JavaScript API, which allows Unity developers to send commands to this ball. So we were able to actually synchronize these physical movements of the ball with the animations of the agent. And this is also open sourced in case you want to use such a ball in your research as well. For the second virtual physical interaction, we wanted to create the illusion of a virtual agent writing on a real sheet of paper. And you can imagine that, that this prototype was a little bit more engineering work. So we were searching for smart material that could be affected by external stimuli. And there are different options here. So we could use materials that are sensitive to temperature changes, to UV light, to fluids. And actually, for this project, we ordered all of them. And we were also consulting our chemistry department. In the end, our choice fell on thermochromic ink. And this is invisible if temperature is above a specific activation temperature, which is 47 degrees Celsius in our case. Don't know it in Fahrenheit, sorry for that. And this gets visible as soon as the whole paper and the thermochromic ink is cooled down again. So we integrated a Peltier element into our table. It was mounted right below the surface of the table. And the polarity of this Peltier element could be changed to heat it up or to cool it down in the different phases of the interaction. For our study, we wanted to have a first proof of concept. So we prepared a sheet of paper with thermochromic ink. We were actually writing a score on it. I will explain why in a second. And then we heated it up before the experience. And then it gets invisible. And then during the human-agent interaction, we were able to cool it down again to make it visible again, so that for the participants, it had the impression that the agent was actually writing something during the experience. For the user study, we invited 40 participants to play a mini golf match against the virtual opponent. And I know that based on the sample size, the between subject study will naturally yield a low power, but still we decided to do a between subject study instead of within subject, because we wanted to make sure that the users are not biased by the agent capabilities they saw in a previous trial. We chose a full factorial design. So each agent was either playing with a virtual or a real golf ball and using a virtual or real handwriting. Since we chose this between subject design, each study participant only interacted with one of these 4 agents that I just mentioned. As you can see in this short video, we prepared a mini golf course with physical elements such as obstacles in the hole. And when entering the study environment, the participant first walked to the terminal table with an apparently empty scorecard on it. And together with the experimenter, the participant prepared a table with the names of the participant and the virtual agent, and with blank spaces for the scores. Afterwards, multiple rounds of mini golf were played with alternating turns between the virtual agent and the user. And here in this video, you just saw a condition with a virtual agent playing a real golf ball. So this was one of 4 agents that we just saw. And we used motion capturing to generate these animations that you saw that are synchronized with the predefined path of the physical ball. After the virtual agent putted the ball into the hole, she walked to the terminal table and she first wrote the score on a sheet of paper virtually. So by this means, we could simulate a smooth motion path in all of the conditions, not only the virtual ones. And for the physical handwriting condition, this virtual score faded out at some point, and the physical score, which was written earlier with thermochromic ink, became visible. After the mini golf match, we encouraged the study participants to take the scorecard home as a souvenir. And surprisingly, most of them just realized in this moment that there is actually a physically written score on a card. During the study, we logged some observational data, such as the participants' trajectories, and we also asked participants to fill in a number of questionnaires, for example, for presence, for engagement, ecological, validity, and so on. And here you can see two of them, which are quite representative of the results, unfortunately. So you can see that the quantitative results are rather similar for all four conditions. For engagement, and surprisingly also for ecological validity, where we really expected that there would be a difference between agents without and with virtual physical interactions. Nevertheless, we made some interesting observations during the study. So 6 of the participants filled in the score of the virtual agent in her stead. So apparently they anticipated that the agent cannot do it anyway, so they did it for her. Also, we found that 13 of the 20 participants of the physical handwriting group didn't notice the handwriting was persistent. So even after they took the scorecard out of the cave, we had to tell them after they filled in this questionnaires, actually there is a physical score on this sheet of paper, so they didn't notice. And this indicates somehow that the users are still very used to virtual agents with limited capabilities, which may also explain that they rate agents according to common criteria, such as the rendering quality, such as the speech, and they do not punish missing virtual physical interactions. And why we think that, and we don't think that people just don't like virtual physical interactions, is that the qualitative feedback was really positive. So people were quite enthusiastic about the experience. They said it's more meaningful, more memorable. 7 of them even mentioned that the agent is more realistic in their open feedback, although this was not reflected in our quantitative results. So we have some motivation to further pursue this path and work on these interactions in follow-up studies. And here you can see some ideas that we have for future studies. I don't want to go into detail. I think the main thing that I learned from this study is to use scales with higher granularity. So this is actually something we already applied in our follow-up studies, because we realized that if you have a scale between 1 and 5, 1 is it's a robota, 5 it's a robot, sorry, 5 is it's a human, then a lot of people will just select 4 because they say it's almost like a human but not really, or they say it's not really human-like, but at least it's more a human-like than a robot. So we realized that we should have more intermediate steps to get better feedback, or feedback that we can analyze better. And we are also actively researching right now an interactive table, because in our current setup, a limitation was that we always had to prepare the text, so the agent cannot write just what comes up during the interaction. Okay, third question. It sounds simple, but actually it's one with many facets, and one I'm really excited about right now in my research. Do agents need to be customizable? And if you are a gamer, you're probably familiar with such menus that you just see of character creators. And they have tons of options regarding clothing, hairstyle, and here you can see even for some facial features. So in this example of Build Wars 2, you have 5 sliders to just adjust the shape of the nose. The question is, do we want to transfer this kind of customizability to agent as well? Maybe not in the same scope, maybe a little bit more limited, but in general, do we want to have customizability? And again, I would ask Aladdin to share the third survey. So what is your opinion on that? Do you think, yes, in general, we want agents to be customizable, or no? we have, we have results. Yes, okay, this is a clear result. And it's interesting because it's the third time that the majority of you select an option which is actually not human-like, but which is kind of artificial. So again, if we would aim for a perfect simulation of humans, then the clear answer to this question would actually be no, because if you go to your doctor, you cannot exchange his haircut beforehand. You cannot say you should have a friendlier face just because you feel more comfortable then. And yeah, nevertheless, I understand that for virtual agents, there are a lot of good reasons to say like we want to have that because we have the option, why not using it? So here are some advantages what agent customization could be good of. So first of all, this is what I already mentioned. If we stick to this health domain, it could actually lower the barrier we have to overcome, for example, to make an appointment with a doctor or to go to the doctor for medical checkup. What we also could do, and this is again important for my project in museums, we could tailor our experience. So we could, for example, provide different content to different visitor groups, which is quite natural, for example, for children and adults, that they need to have different content which is delivered differently. But of course, for the same age group, it could also be interesting to customize this because everyone has different interests, everyone has a different learning style and so on. And then the third advantage on the slide is that creating agents that users feel comfortable with when they talk to them could actually create something like a safe haven. And of course, this is important for insecure people, but I would say for every user, basically, it would be nice to have an agent where they really feel comfortable. So given the seemingly overwhelming benefits of agent customization, the question is this the exception? So do we want to have human-like agents, except for that they should be customizable? And I have some bad news here as well. So of course we have these positive things, but they are also coming with some disadvantages. And I write hypothesized because these are things that we are researching right now. So we have different projects in this field. And I hope I can tell you more about empirical results later. But for now, I just want to present you the ideas or the concepts behind it. So one first advantage, I mentioned it before, it could just disrupt the illusion of interacting with a real human being. So the question is, do you still perceive a virtual agent as real or as realistic when you just changed his head 2 minutes ago? And a follow-up question, of course, is if it would break the illusion, then how long does this effect persist? So is it something that it's just for two minutes and then we are used to it? Or is it an effect that could persist longer? A second point is that if we would offer a lot of options, if we would allow users to freely customize any agent, that we also run the risk of creating unhealthy beauty ideals and to reduce the diversity of our agents. And this is something that I not came up with, but it's something that we already experienced in related fields. So for example, if you look at the spectrum of avatars that are created when users have complete freedom in their design, and this is the case, for example, in this application VR chat, we still find that there are certain trends. We still find that some body types are not equally represented and that certain beauty ideals are reflected. And this is something that is also supported by research. So for example, Löwen et al., which is shown here, asked 125 participants to estimate their own avatar creation style. And actually only 21.6% indicated that they are aiming for an avatar that is as similar to them as possible. But on the other hand, 54.4%, so more than the half, reported that they tried to create idealized versions of themselves. And 24% said that they tried to create an avatar which is distinctly different from them. One might ask, is this even a problem? So if this is how people want to express themselves, maybe it's okay like that. But there's also a lot of research on the potentially negative effects of such things. So for example, Aparicio Martinez et al. Conducted a study with 168 women, and they tried to consider the social media behavior in connection to satisfaction of the participants with themselves, with their own body, and so on. And what the researchers found here was that addiction to social networking sites, so Facebook, Instagram, and so on, correlates with beauty stereotypes, with a lowered self-esteem, and also with a thinner body image. And we find similar results for other media as well, not only for games or for social media. And therefore the question is, would these negative effects also be transferred to virtual agents if we have the freedom to create any agent that we want? A third hypothesized disadvantage emerged during our own research in the context of museums. So I mentioned earlier that in museums, we would expect that customization has a massive positive impact. But at the same time, we also wondered whether providing museum visitors with customized, individualized experiences could also somehow break up the social group. And this is actually something our project partners from the Bauhaus University in Weimar experienced firsthand when they visited the museum that we are collaborating with. So they realized that just by using audio guides, they started to separate from each other and they didn't interact with each other anymore. So it was a quite isolated museum experience in the end. And this was the case although they only used voice-only agent and although all agents actually told the same content. So it was not really customized. It was just that they maybe could start the audio at different times during their visit. So therefore we could imagine that if we transfer this to a larger scope, like in a metaverse, where every person, every user could have his own companion, which is very different from everyone else and which is maybe even not visible to others, then we can at least hypothesize that this could somehow impact the social dynamics in this field. And since we are so interested in that, we are currently conducting a user study with 2 people visiting a virtual museum. And we are testing different forms of separate and shared virtual guides and see how this changes how people perceive their museum experience. Hopefully I will be able to share some of the empirical results in the future. So here you can see the visually very different agents. On the left, you can see a character from a poem of Goethe, who's a German writer and poet. On the right, you can see a representation of Goethe himself. And the black avatars, I highlighted them here, are the 2 visitors which are participating in the study. So what we saw in summary, that the seemingly very favorable feature of agents to be customizable may also have some implications that we should be aware of. And again, the question arises, can we still create these individual experiences, but also avoid potential negative side effects? One option that we explored in the past is offering a range of predefined options. So for example, we can see here 3 virtual coaches, which are not only different in their appearance, but they also have varying personality and also varying training style. And a direct consequence of creating such predefined agents is that we can simulate reality better, because we cannot choose every single aspect of humans, but we can, at least to some extent, decide freely with whom we want to interact, who should be our inner circle, and so on. In contrast to real situations, we could even create a larger range of predefined options. So while you maybe only have 3 options, if you want to look for a life coach in your region, for this virtual life coach, this limitation is just removed. So we can actually cover a lot of different user types. Regarding the distorted beauty ideals that I mentioned earlier, such predefined agents might not only not support them, but actually they could work against them. So for example, if we create these agents as a whole, we as a developers, we can decide if we want to break some stereotypes, if we maybe want to include some characteristics that are perceived unfavorable at first glance. And if we can somehow decouple, for example, personality, skills, and appearance, which should be the case anyway, but I showed you earlier that for avatars, this is not really the case. A second approach to adapt the agent's behavior to the user is a concept we know from human-to-human interaction, which is called mimicry. And this is the imitation of another person's actions. So this could include yawning, posture, face touching, and you see here even things like food consumption. And this process of mimicry occurs fully unconsciously, and it's usually initiated seconds after a user observed these actions that are to be mirrored. Unfortunately, so far, these effects have only been partially demonstrated for human-agent interactions, so it's still an open research topic. And one possible reason for that may be that mimicry effects are usually quite subtle. So they could go unnoticed even by our subconscious mind if there are too many distracting factors. And this is something that we observed ourselves when we were researching mimicry of speech style, because a lot of our participants were distracted by many different factors. So some of them were extremely focusing on the eye gaze behavior. Of course, we didn't tell them what we were researching, so they really thought there's a difference in the eye gazing behavior and observed it very well. Others said that they didn't like that the agent is expressing an own opinion and not only executing commands. And here, I think this development and our technology gets better and better would be very beneficial, because this means that at some point we can really isolate these mimicry effects and do not care about other distractions, like that the visuals or the speech is not perfect and still has artifacts. Okay, last question. I'm not sure. I think I'm a little bit over time already. I hope it's still okay. So, do agents need to simulate human imperfection? And again, I'd like to start with an example to give you a better impression of that.
Can I book a table for Tuesday the 12th?
Okay, cool. And how big is the party?
It's for 2 people.
Great. And when did you say they want to come in?
Tuesday at 7 p.m.
So what you just saw is an example of Google Duplex. It was developed to make phone calls for you and settle appointments. And hopefully you realize this hesitation of the agent, and also filler words like which are of course not necessary, but which were included to make the virtual agent more human-like. And there are much more of these human imperfections, except for these speech disfluencies that I just showed. So humans do forget, they are slow in many regards, they make mistakes. And then on the right side of the slide, we go into the range of very bad human traits, that they are lying, committing crimes, or exhibiting some social biases. And the question again, do we want to simulate this in humans? Again, a survey, please. And I have a feeling about the tendency, but this case, actually, I give 3 options, not only yes or no, but also maybe yes, but we have to draw a line. Not all of them should be simulated. Okay, let's see.
It looks like we have only 4 answers. Oh, 5.
It's okay.
Half of the people here. Do you want me to wait or?
It's okay. Thanks. Okay, that's somehow expected, but also surprising at some point, because I asked other people as well in the past, and a lot of them actually selected the first option. So they said, for example, if you attended the SIVA workshop where we talked with our keynote speaker, he said, all of the imperfections should be integrated. We need to have a common model. So we need to have a simulation of humans, and it's really difficult to draw the line. But here we can say that this is, of course, not something that everyone would agree on. One interesting aspect is that even if we want to simulate human imperfections, this is a quite complex task, to be honest. So, for example, a lot of human responses are incorrect, but they are still far from being random. So there is one article which provides a very interesting example, I think. It's by Douglas Leonard and called Building a Machine Smart Enough to Pass the Turing Test. And his example is, what should an agent respond if the question is, what is 4,212 times 5,107, for example? And you can imagine that some responses, like, for example, 20,207,012 are somehow wrong, I assume. I hope that it's not correct. This would be surprising, because I just made it up, but they are somehow plausible. And then there are other responses like 0, which is really not convincing. 42, pi, 0, not 0, sorry, I said this before, negative values are also not plausible, or values that have some fraction in the end, so like 0.12. So there are a lot of answers that a human would immediately know, no, this is not correct and it's not plausible. And if we want to simulate such imperfections, we would have to make sure that the agent is somehow giving wrong answers, but not random answers. So difficult thing to do. And again, if we want the agents to pass the Turing test, we would have to make sure that these imperfections are somehow included. We wanted to explore this a little bit with selecting one specific imperfection, which is temporal imprecision, which is, among other factors, caused by a limited memory capacity that we have. And for this, we first conducted a survey with 63 participants, and each of them had to answer 18 temporal questions. Questions included something like, when was the last time that you ate something? Or when did you start filling in this questionnaire? And we collected all of the responses and clustered them in a content analysis. And we came up with 2 core variables. The first one, time format. And there we found 3 different levels: numerical locations, for example, July 4th, conceptual locations, for example, day before yesterday, and also distances, for example, 2 days ago. And then the second dimension would be time granularity, which goes from seconds to years and somehow represents what is the smallest unit that is used in the temporal expression. And what is even more important maybe is that for the temporal distances, so for the third category, we also found some rounding values that are most often used, something like 5 minutes, 30 minutes, 1 hour, and so on. So I think it's not surprising that humans use these, but we could empirically create such a set of common values that can be used for virtual agents, for example. And this is something we did. So we took all of the patterns that we found here, for example, that conceptual locations are usually used with day granularity, and we transferred them to a virtual agent and conducted a second study with this agent. 24 participants were invited, and all of them experienced 4 conditions. In 2 of them, the agent was giving very precise answers, and 2 of them, he used imprecise language, for example, these rounded temporal distances or words like approximately. Our hypothesis was that imprecise agents would be perceived as more believable, but also less useful. And that's a kind of dilemma we wanted to resolve. So therefore, we thought about human coping strategies with limited memory. So what would a human do? And the typical strategy here is to use a memory aid, for example, a calendar or notes. So we included this as a second variable. So some of the agents were checking digital notes. 2 of the agents were answering immediately. And here you can see our setup. It's surprise, it's Louise again. She had a lot of appearances in this talk. So she was helping the study participants to answer some questions. So it was a collaborative task. And as I said, sometimes she was very precise, sometimes not. Sometimes she was checking her laptop for notes, and sometimes she was answering immediately. And the participants evaluated the interaction in terms of perceived anthropomorphism. You can see on the x-axis the 2 levels of agent precision. And what the dark blue line shows is that virtual agents that were not using a memory aid were perceived as significantly less anthropomorphic when they provided precise answers instead of imprecise ones. On the other hand, agents using a memory aid got similar anthropomorphism ratings for both precise and imprecise answers. So we actually found a significant interaction here. For perceived usefulness, we expected a main effect of precision, but what we actually found was a significant main effect of memory aid. And one explanation for this could be that the recall of a piece of information from memory may be perceived as less reliable than when the information is somehow looked up in the notes. So what did we learn from this project? There were actually a lot of lessons here. Through our first survey, we could confirm that humans tend to use vague time statements, and we could also create a set of rounding reference points. Something that I didn't show you today is that we also repeated the survey in 3 other countries, in Japan, the US, and India. And we found that there are actually some intercultural variations that have to be considered when implementing virtual agents. Then our main study suggests that if you are using a virtual agent with human-inspired ways of expressing time, then this will increase the perceived anthropomorphism. It also suggests that when precision is of major importance for specific scenarios, for example, if the agent is actually your personal assistant, then maybe a memory aid like a calendar or notes could help. And just based on these results, we still cannot definitely say whether users actually like these imperfect agents or if they just say they are more human-like. And therefore, we also asked them, what do you think? Which of the agents would you prefer for different contexts? And here you can see that the preferences were context dependent. So for example, for virtual assistants, participants would prefer very precise responses, but for virtual coworkers and virtual friends, most participants would prefer imprecise responses. So again, we would have to adapt our model to the context. Based on these first positive results, we are currently exploring other forms of human imperfection. For example, here you can see a chatbot who shows some typical human behavior like spelling mistakes or like specific time the agent needs to respond. And again, if we stick to our initial question, how much realness does a virtual agent need, then if we want to have a perfect simulation of a human, then we would need to simulate all of these things, but it's not really clear if users actually want to have that. So this is something we are currently studying. And another project led by my colleague Celeste Mason is about human imperfection during virtual coaching. So both for coaches themselves and for virtual companions. And the hypothesis is that virtual companions who show a similar level of exhaustion, for example, by sweating, heavy breathing, and so on, may make the training experience less frustrating for users. And this could be interesting for a lot of settings, for example, when working with seniors. Okay, almost done. So if we go back to our initial question, how much realness do virtual agents need? I hope that you get some impressions on that. Probably you also saw that it depends on a lot of things. So what should be clear by now is that realness is not about a flawless visual appearance or flawless synthesized speech, and that implementing human traits into virtual agents can increase a lot of measures, for example, social presence, credibility, and so on. What we also found is that there are some non-human features that are somehow preferable, for example, that we have customizability or that we have unlimited memory in agents. And one suggestion to keep these without losing believability would be to also simulate human social behavior, for example, mimicry, or human coping strategies, such as using a memory aid. So we still try to keep natural, although we try to support these supernatural features of agents. And in all cases, it's very important to consider which broader social implications our design decisions have, for example, on beauty ideals, what I just saw. Okay, and with that, I'd like to conclude the talk, move on to the discussion. Thank you a lot for listening and participating in my surveys. And yeah, I'm happy to discuss your opinions on the topic and maybe also your questions.
Amazing. Thank you so much, Susanne. If anyone has a question, please either speak up, write your question, or raise your hand. I have a question to start with, if you don't mind. So you mentioned at the beginning about user preference, and that it seemed that in the survey, most people preferred voice, voice only. And also through other experiments you did. So some of the realism or rendering in these virtual avatar is different. I was wondering if you think this is related to the rendering at that time, or is it something else? Because you mentioned voice only when when people work with agent repeatedly.
I agree. I think rendering quality is an issue right now. Although for some of the studies, we actually, for example, for a mimicry study, we repeated the whole study for an agent without rendering, because we thought like maybe it's the body that is too distracting. And then as soon as we did this, people started to complain about the voice. So they just changed their focus somehow. And for the embodiment studies that I showed earlier, we also asked the participants, or Lucy asked the participants, why did you prefer a specific agent? And for the voice agents, it was always something like they are less distracting, they are not disturbing my experience, they are less intrusive. So it was not really about the rendering, which was annoying, which was not perfect, but it was more like really how does the presence of the agent, in this case, maybe negatively affect my own task.
I see. Thank you. I have a question from Kunal. Do you want to ask your question?
Yeah, I can ask. Thank you, Aladdin. Thanks, Susanne. This is a really interesting topic, and my research is also around the same that direction. So when you were talking about, I mean, thanks for sharing the interesting insights about the disembodiment and embodied agents. So you talked about, I think, credibility, user experience, and preference. So did you observe anything or any insight about the trust, like how much the the user is trusting, whether they are trusting the embodied agent more, or just voice only agents more, or was it similar to credibility or anything, any observation?
Sorry, so if the user what was adjusting, you said, could you just the last
No,
part,
so
could you?
yeah, so when user was interacting with the agent, or did you observe anything about the trust, whether they are trusting
The
the
trust.
agent more? Yeah, or is it similar to credibility? Like, what did you observe?
I'm sure the concepts are related. Actually, we didn't have a specific questionnaire on trust, but I agree that for other scenarios, it would be super interesting to have an evaluation of this, because I think for museums, credibility would be more fitting, because we want to know if what the agent says is true. Maybe it's not super important that we trust the agent, but if we have a different setting, like a therapist, for example, then I agree that we would have to check if this has the same results as for credibility, or if it's maybe just a completely different concept. So yeah, until now we didn't collect this, but I agree it would be very interesting to do so in the future.
Okay, thank you.
Thanks for the question.
Thanks, Kunal. You have a question from Ishan. Are you here? Do you want to ask your question? So he wrote the question in the chat. He asked, have you ever included physiological sensing with respect to avatars? I guess that's an input.
We did, but mainly when our studies were about stress, anxiety, and something like that, if this is influenced by agents. And we could see that agents have an effect here. So for example, we could use agents for exposure therapy. So if we want to train people to present something in front of a lot of people, then we could see that agents have a similar effect as real humans have regarding our physiological responses, that our heart rate goes up, that we sweat and something like that. So in this context, we used it, and we got positive results. For the other things, like the museum stuff, we didn't do it, but also because we were not really interested in the stress level or something like that. But I think I mentioned it for one of the studies. So a lot of the studies were somehow based on subjective responses, and which is somehow also related to the technical capabilities that we had when doing these studies. And for some of them, I would really like to include some more objective measures. So at least to see how are people behaving, how do they keep a distance to the agent, are they avoiding the agent, is something that we actually saw very often, that users are not willing to walk through an agent, which is of course also a sign of presence already. So yeah, we would like to include them more often in the future. Yeah.
Thank you. Question from Juan.
Yeah. Thanks, Susan. This is really a great talk. You have involved really interesting topics like overtraded body and to be physical or to be customizable. This is really interesting. But my question is, for virtual agent or virtual human, it might have voice and also have those bodies with behaviors like gestures or postures like this. Do you have any idea on the coordination between those speech and gestures? For example, while I'm speaking, I'm also coordinated with my gestures. So do you have any idea to make this more natural for creating such virtual characters or virtual avatars?
Yeah, we are actively exploring this right now. So in a very basic behavior, which is the gazing behavior, because we realized that in a lot of situations, people just feel that the illusion of talking to a real human is broken because the agent starts to look away right in the moment when they talk to them, and they feel that it's very rude and very not human-like. And therefore, what we are doing currently is that we are collecting a lot of data on how is the gazing behavior of humans influenced, and we do this in VR. Of course, this is not perfectly transferable maybe to the real world, but what is super nice about VR is that we have access to all of the different channels that you just mentioned. So we can check, for example, is the gazing behavior dependent on what the other conversation partner is doing, if the other conversation partner is gesturing, if it is talking to me, is it somehow related to my own voice? So whenever I start speaking, maybe my eyes or my gaze behaves differently. And I think this would be the same approach if you want, for example, to learn how people somehow synchronize their gestures with their speech, for example. And I think it's a complex task somehow, but we are now in a time where we are able to build such machine learning models ourselves, and we are able to use them in a live conversation. And what we try to do, and I hope other groups are doing this as well, is that every model that we trained will be open sourced at one point, so that hopefully we can somehow integrate all of them in one agent so that the agent really gets realistic. So yeah, I think machine learning is would be the best way to do it. Otherwise, what we are doing right now is using rule-based systems to say like, okay, for example, for gazing behavior, there are some points of interest, and the user should, or the agent should look at the different points repeatedly with a specific stochastic model. But as I said, these rule-based systems are not perfect because there are just some situations where you really would expect an agent to look into your eyes and not look somewhere else. And this applies to the gestures as well, I think.
Yeah. So I think for those virtual characters behaviors or coordination between those behaviors, as far as I know, there can be some approaches like data-driven or data-based. That is, they kind of like avatar manipulated by another people. So the real people's gestures or body movement is tracked and mapped on the virtual character, but the participant does not know this is controlled by a real human. They believe that is a virtual character. This is also called Wizard of Oz. I'm not sure. So this is quite related to the implementation or engineer side of the research. Have you ever used this approach in your research? I mean, the Wizard of Oz, to make the characters more natural?
I mean, a lot of our past studies included a Wizard of Oz part because it was not always possible to sense all different things. So, for example, in a different direction, what we did for the mini golf game is that there was an experimenter who was actually observing the situation, who was counting how much turns or how much, what is it called, strikes? I don't know, how often the user actually touched the ball. And this was then again included as an additional knowledge source to our agent. So the agent perceived a little bit more intelligent that he actually was. And for the time study with the temporal imprecision, we actually, I think it was the first time that we actually wanted to have an agent who is a little bit more intelligent, who can recognize the intention of the user and give automatically some responses. And what we found is that we didn't find it, it's just feedback from the reviewers. So we got reviewers who said like, that's perfect. So actually somebody shows that we can use these intelligent systems in real applications. And then we had the other reviewers who said like, you should have used a Wizard of Oz scenario, because for user studies, of course, it it may influence the comparability between different participants if we use these automatic systems, because we cannot perfectly make sure that the whole sequence of things is the same for all participants. And I'm not really sure, to be honest, what would be the better solution here. I think we did both. Also, after this reviewer feedback, we did both. And again, I think it really depends on what you want to focus on in your user study. Do you want to make sure that the user has the feeling that he actually has a lot of freedom, that he can talk about anything that he wants? Or do you want to make sure that it's perfectly comparable? So I think there is kind of a trade-off here. But I agree with what you said. I think in some situations, Wizard of Oz scenarios are still the way to go, because they're just much more controllable in comparison to these intelligent versions.
Yeah, thanks. So, sorry, I have a last question. So for your last topic is the, does agents need to simulate human imperfection? So what I want to discuss is the imperfection should not equal to erroneous. I mean, for example, the virtual agent, there is a virtual assistant. The user might ask, when should I take my medicine or take the tablets? Yeah. So the virtual agent might say, it should be around 3 o'clock. But if the virtual agent make a mistake, for example, in real life, people might also make mistake for memory those dates. So it's around 3 o'clock is also kind of not impression expression. But if the virtual agent make mistakes on such dates, it might cause some safety issues, right? Yeah, so I'm not sure, do you have any comments on this, the imperfection or the errors made by the virtual agent?
I completely agree. Actually, I can tell you, if I would answer this last survey, I would also pick the medium option, because I think that, of course, we want to be human-like, but at one point we also want virtual agents to be as useful as possible for us. And we don't, as you said, we don't want to put users into danger just because the agent is very human-like. So I think this would be a bad approach here. So what we describe in our paper is that in some situations, it might be better to, for example, also switch to the absolute values. So if you remember the table that I showed with the different categories that we found, then we also saw that users can do some very precise responses. So for example, if they think that it was a very meaningful event, so then people are better at memorizing the time, for example. So it would be still possible to let agents use such very precise statements if we somehow can justify it. So for example, because we know the agent is trained on that and he has his notes and something like that. So I think for all of these imperfections, my suggestion would be to say, try to be human-like, if it's not crucial. So if this is actually something that the user is preferring because it feels like a more natural interaction. But as soon as the information that the agent is giving, then we really have to try to find workarounds which still keep the agent believable, but make sure that he can help the user the best he can. So yeah, I completely agree with you. And therefore, it's interesting that in this group, nobody said like, yeah, every imperfection should be included.
Yeah.
Maybe it was also because in the workshop, when I asked the keynote speaker, we didn't talk about criminal acts, for example. Maybe then this would have changed his mind. I'm not sure. But yeah, I'm always interested in collecting these opinions.
Yes, thank you. So I think I read a paper that talking about if they were treated or if agent makes mistake, whether participants will forgive them or not. Something like that. Yeah, I think this is also a really interesting topic to research.
Actually, maybe I will write you afterwards because I'm interested in all. Maybe you could share.
Yes. Yeah, thank you. Thank you so much.
Great questions. Thank you. Do we have any other question or no? I had last question, but I think Joanne asked which about the imperfection and where is the line. I guess now we have an arbitrary definition of the line. And I guess we didn't want to deceive people to say this is not like in the Google example. I guess the restaurant or the cafe person didn't need to know that this is actually Google Assistant to making the booking rather than human. And I guess this comes to question of ethics approach as well. And it brings up another question, but I don't know, maybe for later, when it is asked about, you know how in self-driving car, they say the ethics about if it has to kill its owner or the pedestrian because it's two options only. Do we have similar question for virtual agents, and have we looked into these? I guess, but
that's a tough one. So maybe regarding the deceiving part of your question, the first part. So what I cut from this Google Duplex video was that actually in the beginning the agent was still saying like, "Hi, I'm a chat or I'm a virtual assistant. I'm the Google Assistant. I like to make an appointment." So although the agent tried to be very human-like throughout the conversation, he actually made the conversation partner aware that it's not a real human in the beginning. And I think this is the way to go for all the agents that we have. I think the user should always know that he's currently talking to a virtual agent, which of course could diminish the believability or the presence in the beginning, but I think it's just necessary. I think it's nothing we have to discuss. I think we have to do it, and we have to think about how can we still create plausible illusions, or how can we still make sure that the user has the feeling to talk to a human. Regarding the other point, I'm sure that there are similar decisions for virtual agents as well that you just mentioned for the autonomous cars. So for example, a lot of our projects are in the health domain. I would say 50% of our agent projects are in the health domain, so in caregiving, in therapy, and so on. And I think there are a lot of ethical things that we have to consider, maybe not regarding this direct comparison, who should survive, but I think it's also important if you have a virtual psychotherapist, for example. I think this is a super sensitive thing where we have to be very careful what to say. So even if we say the virtual agent is just assisting a real doctor, I think it's still super important to make sure he does the right things, right? He says the right things to a person who is maybe especially vulnerable. And I don't have a specific ethical point in mind, such as the thing that you mentioned, but I'm 100% sure that we will face such things for virtual agents just as we do for other technical systems.
Amazing. Thank you. There has been a very informative talk. Thank you so much for sharing your knowledge and expertise with us. There was a question at the end. If you can share your slides, we would love to receive that. I can share with the group later. And of course, this is recorded, so we'll send you the link afterward as well. Thank you again, everyone, for being here. Thank you so much, Susanne.
Yes,
Thank you
as well. It was a pleasure, and thank you for the great discussion as well.
Thank you.
Thank you. Bye-bye.
Thank you. Good night.
Okay. Thank you. Have a great day.
Thank you as well. I'm just checking if I missed something in the chat. but I think you were a good moderator. So
Oh,
you
thank
already mentioned it. Yeah, so thank you so much for organizing everything. And sorry that I think I was a little bit over the time limit. I
Oh,
hope
no
that's fine.
problem. It was
Okay.
really interesting talk. And if
Yeah.
you get an opportunity to visit New Zealand, we'd love to host you here
Actually,
as well. Yeah. Are
I
you?
just submitted something because VR was not taking place, and I was so sad
Oh, yeah.
because I could finally go there, but maybe it will still happen.
Next time,
So,
yes.
yeah.
Hopefully.
Have a great day and see you.
You too.
Bye.